Do you think I'm drawing a fortress here now for my kids to play with? Well, not quite right. But what this here has to do with a perfect weld seam, I will tell you in a second. So today I would like to talk about welding methods. In recent videos we were talking about electrodes, etc. But now it's about the welding method itself and what's the different and let's say the common features of weldings, for example, regarding smaller dimensions and bigger dimensions. So what do these methods have in common and what are the differences? So in general, a welding method would start with certainly putting the welding head around the tubing system and starting at a certain area, rather 3 o'clock or 9 o'clock, and start a pre-purge time. That's certainly necessary to flush all the remaining oxygen out of the welding chamber. While the oxygen level is reduced, at some point the voltage will be cranked up to a value of roughly 5,000 volts, and then the arc will be ignited towards a high current level. Then we will start the welding process, and certainly the material gets warmer and warmer during these welding process. And that's why we separate a tubing into 4, probably also 6 different sectors. So first sector, second, third and fourth. And this material is constantly getting warmer and warmer. And that's the reason why we can slower or lower the current that we apply here, because the material is warm already. So that's what usually the welding processes have all in common. And we also do not weld 360 degrees, but rather 370 degrees, because we need a certain overlap on this. So, but if these are the common features, what are the differences? So in this case, it's a 1.5 inch tubing I have here on the table, and that's usually a pretty small wall thickness. So there we can apply a continuous welding program. What does that mean? Also here we have a high current and a low current, so a pulsed current in there, but the electrode is continuously traveling around the tubing because we have enough energy that we apply, and we can always keep the electrode traveling. So the energy is high enough to fully penetrate the weld seam in this case. If we want to achieve also with diameters like this, 4 inch, and wall thicknesses above 2 millimeter, we would use a very high current to establish the same. That would in return lead to some kind of uncontrollable parameters and probably a weld bead width which is getting higher and higher during the welding operation. Furthermore, at the end of the day, the discoloration of my weld bead will not be perfect as we would like to have it. So what are we doing? What we can do is we can apply a so-called step mode for this program. That means that we keep the electrode traveling to a certain point when at a low current level, and then we set it to a high current level and we stop the electrode. At this stage, the electrode or the electric beam or the electric arc will constantly fire at the same point. And the reason is there, what is happening, we will penetrate fully this spot. At some point it's stopping, we're going to a low current level, and then we're applying high current again. So we are having like either circles or ovals that are overlapping by roughly 75%, and we will create this typical, I would say, pattern of a step mode weld seam where you see these overlapping of circles. This, at the end of the day, as mentioned already, will lead to a pretty well formed weld seam, which is created by this step mode and which has very good controllable parameters. The difference is certainly, as mentioned, it's kind of a trade-off between time and energy. At the end of the day, we bring the same energy in, but we here apply a higher time in order to put in more or less the same energy that we would need to penetrate a lower wall thickness. This is what I would like to tell you about these two different methods which are in general applied in hygienic tubing systems. So if you have any questions, please let us know. Don't forget to subscribe to our channel and stay healthy.